The moon needs Einstein. NASA is preparing to return to the moon with the Artemis mission. But what if I told you this mission depends on an idea that is more than 100 years old? Not a modern computer, not artificial intelligence, a theory written by a man who never saw a rocket launch, Albert Einstein. And without his ideas, this mission would not work. To understand why Einstein still matters today, we need to understand how space really works. Because in space, things don't behave the way we expect. When a spacecraft travels to the moon, everything depends on extremely precise time measurement. Not just seconds, but tiny fractions of a second. Even a small error in time can send a spacecraft thousands of kilometers off course. But here's the problem. Time does not move at the same rate everywhere. Einstein showed that time actually slows down in space. So NASA must constantly correct and synchronize time, just to know where the spacecraft really is. Time does not pass at the same speed everywhere. Closer to Earth, gravity is stronger, and time moves slightly slower. As you move farther away, gravity weakens, and time speeds up. But there is another effect. Objects in orbit are moving very fast, and motion slows time down. So which effect wins? In the case of satellites, gravity wins. Time actually moves faster in orbit than it does on Earth. And this tiny difference must be corrected every single day. Reaching the moon is not about flying in a straight line. It is about following a precise path through space. These paths are shaped by gravity and by motion. Every movement of a spacecraft is calculated using these invisible curves. NASA does not aim directly at the moon. It places the spacecraft into a carefully designed trajectory, one that naturally leads it there. And those trajectories only make sense because of Einstein's understanding of space and time. Einstein didn't just change how we understand space, he also changed how we understand energy. His famous equation revealed that mass and energy are deeply connected. This idea became one of the foundations of modern physics, and it helps scientists understand how powerful systems behave, including those used in space exploration today. Even communication with spacecraft depends on Einstein. Signals traveling between Earth and the moon are affected by both gravity and time. Without correcting those effects, data could arrive with errors or delays. Even a small distortion can become a serious problem over long distances. So every signal sent to a spacecraft must account for relativity. Einstein never worked for NASA, he never built a rocket, he never went to space. And yet, more than a century later, his ideas are guiding humanity back to the moon. The future of space exploration is still written in Einstein's equations.